So Elon Musk says the future must look like the future. And I'm telling you, we're living in the most brilliant of times when science fiction is fast becoming reality. Flying cars, humanoid robots, artificial intelligence, and now massive AI data centers in space. So Elon believes he can scale Starlink satellites not just for global internet, but as orbital data centers for AI, massive amounts of compute powered by the star at the center of our planetary system. I have Brian Wang with me to help us make sense of all of this. Brian is an expert deep tech analyst investor. He's a futurist thought leader, and he runs the prominent science blog nextbigfuture.com, and he has a YouTube channel by the same name. Welcome, Brian. I've been looking forward to this chat with you.
Great to be here. A lot of exciting stuff.
It is so exciting indeed. All right. You've done all the hard work for us, for me and my viewers, because this is such a complex topic. It is so fascinating. It is so profound. It tells us we're living in the age of science fiction turning into reality. And I don't know if I can find a better way to describe what we're all witnessing. So without further ado, let's get your slides up. And please, can you just take us through this amazing future that could be just a year or two away?
Okay, so everyone knows we're making huge AI data centers. XAI is completing which Elon Musk runs, is completing a 1 gigawatt data center that has 500,000 chips, and they'll soon, by next year, they'll have 2 gigawatts, and they'll have 1 million chips there. Each one of those chips is made by NVIDIA, and there's other making chips, but NVIDIA is the dominant player there. And there's $300 billion being spent on AI data centers every year. So it's a huge amount of money. So what's recently happened, we see this thing on the left, StarCloud, is a rendering by a startup company with about $20 million of funding, and they're working with NVIDIA. On the right, we have Starship. And Starship is critical for this plan, which Elon Musk and Jeff Bezos says will move AI data centers into space. Elon put out a target of 100 gigawatts possible in 5 years. That's a bit, actually, I've done the detailed work, that's a bit more than can be done. Not necessarily because of what SpaceX can do, but because of what TSMC can do. They won't be quite ready for that.
Right. So StarCloud, just for our audience's benefit, has just launched a trial. What would we call it? A rack?
Satellite? No, one chip.
Well, it's just one chip. It's one H100.
One H100.
All right. And do we know whether it's doing any sort of compute at all in orbit?
Yes, it would be doing compute. So they basically launched it November 2nd, so like 2 days ago on Sunday. So this is the one they were doing. It's 60 kilograms, and they have the H100 chip inside. So the reason that's a big deal, even though that's not the newest NVIDIA chip, the newest NVIDIA chip is B200 or B300. H100 is still pretty new, 2 years old. Normally, so this is like 100 times more compute than have been launched in other chips, because you usually launch older chips that you have time to make space ready.
Yeah.
So, yeah.
And that is crazy, because I think it's important for people to kind of understand that we're not talking about these concepts as abstract concepts. It's already reality. You already have an H100 in orbit, circling Earth right now as we speak.
Right.
So it's only a matter of scaling it up. And this H100 from StarCloud went up on the Falcon 9. Right. So it's not as if they're not able to be deployed right away. It's just a matter of scaling it up, and that's where Starship comes in.
Right.
And the entire AI ecosystem.
Right. So then as the Starship launched, we saw the ship. This is what they're going towards. StarCloud, they say they want to make a 5 gigawatt system, and that would be 2.5 miles by 2.5 miles. So 4,000 meters by 4,000 meters to get 5 gigawatts of solar. And then the data center itself will be tiny in the center. This is not what Elon Musk will build.
Yeah.
Okay. So Elon Musk is talking about 100 gigawatts. He will not build 20 of these. Okay. So what's going to happen, the critical part, this is some numbers by
Okay.
Starcloud.
I'm sorry to interrupt, but yeah, can we just go back to that? Because so this image, I think it's important to explain to people, because there's a number there that is 4 kilometers, and that's a bit of a number to wrap your head around, right? So what is it that is 4 kilometers? Is it the solar panels? Is it the
solar
radiators plus all the hardware together?
The solar panels are 4 kilometers by 4 kilometers.
Wow.
The radiators, which would be on the back of it, they could be as big, where you just have matching radiator and solar, or you make the radiators somewhat smaller in size, but still very large. Right.
Yeah. Right.
But it would
like the ISS.
Right. Where they have separate solar radiators.
So Brian, I think in the weeks preceding, so there's been this a flurry of posts from Elon and from Satya and from Starcloud, the CEO. Just everybody, Casey Anmer getting into it. Everybody's kind of fascinated and just so taken up by this future that is just within reach. But in the weeks preceding these, the launch of Starcloud and these announcements by Elon and by Google, one of the big conversations was how in the world do you cool these ships in space?
Right.
Because we're all used to the concept of large amounts of water being used to cool these these massive chips in these massive data centers here on Earth.
Right.
But you don't have water in space. You don't have air. So you don't have conductive cooling. You don't have convective cooling, because space is space. It's empty.
Right. So there's the sun exposed part of, there's the sun exposed part, and then if you have shade, the backside of it. So space is very cold, except where you have a lot of sun. Right. So you have a high temperature and then a low temperature. So the low temperature part can be like negative 150 or something, right? So it's like 100 degrees cooler than anything on Earth, right? But having it very cool, to your point, it's a lot of vacuum, right? So it's not the less, like right now we're using air cooling and water cooling.
Right. Here on Earth.
So here on Earth for our data centers, right?
Yeah.
We want to use water cooling because the water is 1,000 times or several hundred times thicker than the air, right? So then you can get more interaction with material, so you can take away more heat, right? So air cooling is less efficient than water cooling. And then if you're cooling in vacuum, then again, you would want to use some flowing liquid to bring some of the heat away, bring it out, and then have it radiate away, right? So I'd have little channels bringing the heat using some form of liquid, not necessarily water, because water would freeze up, right? So you have to have some other liquidy material, some kind of molten metal or whatever you're doing, to flow the heat out, get it out to the point where, okay, now I brought the heat from the super hot chips out to a really wide area, and then it can just like go away to the vacuum at whatever pace it can go away to the vacuum at, right? But it's not really fast, to your point, to a point about, because water and liquid is the best way to remove heat, most density, most whatever, which is what we're using now. But then you still have to have it exposed, where it's like moving the heat away, liquid, and then go out to the air. Air just goes out. It's less efficient, X times less efficient.
So it's radiative cooling, but it's a problem that's not, it's not insurmountable, because you already have.
We've already been doing it, right?
We're already doing it in space. Just for my audience, when you hear about radiative cooling in space, it's not a problem that we already don't know how to solve. Sure, there will be challenges in scaling that up when you're talking about these massive 5 gigawatt data centers. But then again, you're looking at the scale of these infrastructure projects, and space is big. So
Right.
4 kilometers in space is nothing.
Yeah, but several points of like what has been and what have not been done. We have never made anything nearly this big, right?
Right.
The biggest thing we made is like ISS, right?
Right.
So that is ISS is only about the size of one Starship itself. One
Yeah.
Starship has the volume inside of
The
the
volume
ISS,
inside of the ISS.
right?
Yes.
So then we've only built something with this one Starship load. This would be 1,000 or 5,000 Starship loads
Yeah.
to bring the material up, and then we have to build it, right? So that's why this is not how Elon's going to do it, because we have not built anything this big. It is theoretically possible for us to do it, but we have not done it, right? Also,
Yeah.
things like 5 gigawatts of solar
Mm-hmm.
in space.
Mm-hmm.
The most we've ever put up is SpaceX Starlink in terms of solar
Yeah.
in space,
Yes.
right? And that's across 9,000, almost 9,000 satellites, right?
Yeah.
Each with at most 20 kilowatts of solar, right?
Yeah.
So that means that we have 20 megawatts, 200 megawatts,
Yeah.
200 megawatts or so of solar max, right?
Yeah. A little
So
less. Yeah.
a little less than that, right?
Yeah.
So so that's how much we put up
I mean,
ever.
that is a
And
substantial. That's a substantial amount of solar power generation, and when you factor in, when you take into consideration that solar power generation is a lot more effective in space than on Earth,
mm,
it's incomparable almost.
yeah,
So the limiting factor really has been the rocket that can take your stuff up there and Mars to orbit at scale. And then again, we circle back to Starship
right.
and Falcon 9.
But I don't want to say wave over the fact that yes, we have hundreds of gigawatts of solar on Earth, but
Yeah.
we've only ever put up 200 megawatts into orbit, right? Roughly,
Yeah.
right?
Yeah.
And then the space station, we took up multiple loads to put up its solar power,
Yeah. Yeah.
less than a megawatt. Like it's
Yeah.
like 400 kilowatts from like the original batch, and then another batch they put on later. And the
Yeah.
other thing is that stuff cost $100 million plus.
Yeah.
Like they put the last $160 million. So that cost was way higher than what these guys are talking about. So,
Mhm.
but the lower cost is probably, but not certainly, what SpaceX is doing, because we know
Yeah.
that the total cost is of the Starlink satellites. We have that number roughly.
Right.
So many interesting things. But to your point, one of the key ones is you cannot do this without getting Starship fully reusable. And then we'll go
Absolutely.
into the numbers why that's the case
Yeah.
on the next slide. So
Yeah.
the next slide is that you have terrestrial, which is Earth-based AI data centers, and then space-based. This is what StarCloud was looking at. Only look at the top line. Energy for 10 years, and above that they say for 40 megawatt cluster for 10 years, right? So terrestrial, 140 million, 4 cents per kilowatt hour. That is a rough cost from some of the cheapest energy that you can get from the grid. Okay, so that you're probably in Texas and you're getting 4 cents per kilowatt hour. For a data center, you also have to adjust it by something called power efficiency, power use efficiency. You want to get that to 1.1. Still, rough estimate, 4 cents per kilowatt hour, right? And then for 10 years, you just say, okay, if I'm constantly needing 40 megawatts, that will cost me over 10 years, $140 million, right? And then there's other costs down below that add up to $167 million, so another $27 million of other costs for cooling and for backup power and stuff like that, right? So that is a very ballpark estimate. The 10-year thing is, I disagree with. They should not be using 10-year for this AI data center, because
Okay.
AI data centers on Earth, the chips won't be useful for more than 5 years.
Right. And
Right?
anyway, you'll have progressive generations of chips that will be a lot more powerful, require a lot less energy. So they'll be, you'll have the Osborne effect as well. They'll be
Not
outdated.
an Osborne effect. It's just that
Yeah. I mean, sorry, you're right. Not the Osborne. Yeah.
every 3 years, they're making, or 2 years, they're making a
Yeah.
chip. Like the H100's, 2-3 years old, right?
Yeah.
And it's 1/10 or 1/50th the power of the latest chip,
Yeah.
right? So it's just that after a while, your chip is not as useful because I need to go to the next generation, right? And getting to 5 years involves saying I'm using 2 years for training, 3 years for inference. So inference, meaning I'm using it and selling it to run models, is less dependent on being the latest and greatest. Training
Right.
needs to be the latest and greatest. So that's 2 years of that, and then 3 years. But then, unless I'm switching out the chips, that satellite will not be useful after 5 years, right? So then I shouldn't be comparing against a 10-year lifespan because I'm not going to update it again, right?
Yeah. So hang on. So what do you do with those satellites after 5 years? Do you
just the same
deorbit
thing we
them?
do with Starlink. We deorbit them, we burn them up.
Okay.
Right. So, or theoretically, you could recycle the whole thing, blah blah blah. But I think for our basic calculations, let's ignore that and just say 5-year life. To beat terrestrial, they make claims about kicking, totally destroying terrestrial and being super cheap. There's issues with what they just did there. I'm going to focus on the first step is less than half of this for the 5-year. So basically less than $80 million. If I can't launch a Starship for less than $80 million, then I'm not cheaper than terrestrial. Okay. Right. I'm not cheaper than Earth, right? So where are we right now? Right now, 10 Falcon 9 launches equals 1 future Starship launch. Okay. I'm launching 20 tons at a time. I get to 200 tons, right? Right. So that would give me, so how much does it cost to do 10 Falcon 9 launches, right? So if I'm buying it off the shelf, how much SpaceX will charge a commercial customer, it's about $67 to $70 million for one launch, right? So I need 10 of those, that's $700 million.
Right.
Right. So that is way more than the $5 million they have in line 2, right? Yeah. So then, and it's more than the $80 million that we're saying we need to get under, right? But how much does it cost SpaceX for a Falcon 9? SpaceX, it costs about $20 million, maybe $15 million.
Right.
So because they are reusing the booster, they have lower cost for themselves, right? Yeah. So for SpaceX, let's say 10 launches at $15 million, that's $150 million, right? Close to, but still double the price of the $80 million. Still too high, right? So then you need, in order to get under, and I'm just launching stuff. I haven't, paid for any of the solar stuff yet. Right. So until you get launched underneath that threshold, I'm not past go on getting things cheaper than Earth-based. Although you could have a smaller niche market around, I'm launching more expensive stuff that's 10 times more expensive, 20 times more expensive. I'm willing to pay it because it's doing something special. Because it's, satellite in space, it's delivering something. There's reasons why you might do it for a small case, but not for, I'm going to do 100 gigawatts. I'm going to do 100 times more than my biggest data center here, right? I'm doing 100 times more because it's got way cheaper, right? Okay, so then I done the calculation of the launch. I think they can get the launch, and other people have done it, on a fully reusable Starship. Getting under $10 million of cost is, air quotes, relatively easy. Okay, I don't go to the details of that now, but take my word for it, $10 million on cost. But the thing is, $10 million of cost, SpaceX is not selling that to anyone else, not selling the Star Cloud for $10 million, right? And getting to $5 million, they may be doing. Again, they're not selling that to you. So them putting $5 million in is saying that they have special deal where SpaceX will sell it to them at zero margin, right? Not going to happen. Yeah. And if it does happen, it's not going to happen in 10 years.
Yeah.
Right. So their assumption that they can get to 5 million from SpaceX can maybe do that in 3 or 4 years, right? 5 years. But they're not going to sell it to you for that because their cost on a Falcon 9 launch is 15 million, and it's selling it to you for about 4 times more, right? So the minimum you can say, I'll sell you the same rate markup I'm doing for my Falcon 9, right? So then I'll charge you 4 times more, so $40 million maybe, right? But even dropping below $80 million. Why? Why would they drop below 80 million? I'm selling Falcon 9 launches at $60, $70 million. I get this other thing working. I'll drop my Falcon 9 launches to 40 million for a while or not, because no one else can beat it. So why am I dropping prices when no one else can beat it? Right. Yeah. Anyway, so that's a huge factor on this thing is the cost thing. They're saying $2 million for the cost of a 40 megawatt array, right? And that I have not seen any numbers like that you can get to that cheap. The numbers I'm researching show about $1,000 per kilowatt. So that would mean $40 million for a 40 megawatt.
40 megawatt, yeah.
Cluster, right? But and then I've seen some work by or projections by NASA and Caltech that we can get down to half the cost or a quarter of the cost. But that's still at a quarter of the cost. That's still 10 million. So they're coming up with 2 million. You know, I don't see how they get to $50 per kilowatt.
Yeah, but you know, all things considered, there are other factors that are pushing companies that want to deploy massive data centers from Earth to space. You've got regulations around climate concerns, pollution, just plain regulatory hurdles in countries like America, Europe as well. You don't have any of these problems in China, right? You've got solar manufacturing at scale. They're clearly the best in the world at solar manufacturing. Their AI chips are also fast, becoming getting pretty close to some of the best in the West. And then you don't have any problems with regulatory hurdles. So when you look at a US versus China scenario, and you have all these problems, you have the problems with the energy grid in America, it just makes sense geopolitically as well to move to space for data centers. So how do you factor in these compunctions, these realities of the ecosystem for the industry in America?
So the goal and long-term drivers of it, that after I get it cheaper in space, what I'm saying is there's several things that have to happen before you get cheaper in space, right? And one also, even the doable part is we need to test that H100. They're gonna test it for 6 to 12 months. The reason NASA and stuff didn't just say, hey, let's always toss the newest chip up there. Let's toss the Intel chip up there. Let's toss the whatever chip up there, is because you were making space grade chips.
Yeah,
you had to make them.
It needs to be radiation proof. It needs to be to withstand the temperature gradients. It needs to, zero gravity or microgravity. A lot of these other factors that you don't have to take in consideration here on Earth.
Right. Same thing for the solar panels. Yeah. I don't just take regular off-the-shelf solar panels and toss them up there in space and expect that to last or work any time, because it has to be able to handle the temperature differences. Going from like negative 150 up to positive 100, right? That would, the solar panels on my roof would break and be useless, in like a couple of days, right?
Yeah. So I think we saw something like that happen with was it the James Webb telescope when it crossed the Terminator line before it went into deep space, and there were problems with the expansion and contraction when it crossed over from daylight into darkness. Yeah. So you're right. I mean, these are a lot of things that go into building an equivalent infrastructure for space as compared to Earth.
Right. So up there is a big problem, right? And moving up there cheap enough is a problem. So moving up there is like for the 100 gigawatt plan, right? You're looking at least 5,000 launches, right? So scaling up, like we've done 11 launches so far. You get a fully reasonable maybe happen next year. Maybe you get 30 to 50 launches next year, and then they're only permitted to do max like 100, right? Yeah. So the FAA is only
Are these Falcon 9 launches, right?
Starship launches.
Okay, Starship launches. Okay.
Starship launches.
Right.
Falcon 9, you're good up to about 200, right?
Right.
Falcon Starship, want to get working. I'll be able to do 100 launches next year,
Mhm.
and then
Yeah.
apply to do more, right?
Yeah.
So, and then doing more is if I get them to the rate of doing like not just once a week, but on each launch tower, but doing it like every 2 days, which is
Yeah.
or every day, which is what Falcon 9 can do. They have to give you permission to do that, right?
Yeah. Exactly.
And you have to have the infrastructure, the refueling capability, because I need 10 times more fuel, right? So there's a bunch of logistical things around upping that rate. They're just not just like, oh yeah, no problem. I just go, like 10 times a day, no problem. It's like now you're talking about 100 times the fuel, right? So, and that fuel is like 5,000 tons for a Falcon 9. So like, so it's like a lot of fuel. I don't know, 5,000 tons for the Starship, the Super Heavy Starship, 5,000, 6,000 tons. So it's a lot of fuel that we're talking about here. So there's a bunch of things that have to happen for that rate. To get to 5,000 launches, I'm going to need a lot more launch towers. I'm going to need to have a bunch of launch towers all the place. They're going up to 3 or 4, expanding to 4 or 5. To get to 5,000, I probably need at least 10, maybe 20 launch towers, right? So and again, I have to have the facilities to do it, right? So
Yeah.
the scaling up on that side. So Elon kicking out that term of doing it 100 gigawatts in 5 years. One of the reasons why that won't happen is that means 50 million chips. They must get 50
Mhm.
million chips to launch, right? Besides what I talked about, making sure they will work in space rating, and all that other work. If I don't have 50 million chips, I cannot launch 50 million chips,
Yeah.
right?
Exactly.
And TSMC is trying to ramp to 50 million chips in 2030, right?
Mhm.
Up from like 5 million this year, 7 million next year, right? And then so they want to go up another 7x, 10x from this year, 7x from next year, right? To 50 million. But the thing is, they're not going to give every chip to XAI and SpaceX, right?
Yeah.
They're only selling 10% because like other guys, OpenAI, Amazon, Oracle, they're all
Everybody
buying
is
chips.
they're all
Everybody's
buying
buying
chips.
chips,
Yeah.
right? So then, one, can you even make that number?
Yeah.
And that involves scaling to plans that have that. And then two is how many of those chips will I sell to you versus
Mm.
selling to the other guys? And all the
Yeah.
chips are sold out for the next 2 years.
So are these going to be NVIDIA chips, or are they going to be the
The Tesla
the
chips,
Tesla chips? Yeah.
AI5, AI6. So that goes to
Yeah.
my point is that if I'm not doing this for 4 years, right? Because no launch is ready to go, right?
Mhm.
I could do some tests, but I'm not doing the big thing, right? I'm talking about I'll scale up. I'll do another satellite. I'll do a full load of Falcon 9. I'll do a full load of a Starship. But that's only going up to 40 megawatts, right? So I'm doing the necessary baby steps to make sure this doesn't break. I'm not going to
I see
launch
where you're going with
five.
this. Yes.
I'm not going to launch 5,000 times
Yeah.
before
Yeah.
does one chip work? I need to make
Yeah.
sure before I start launching. I'm not going to spend $2 trillion before I know that I'm not pissing away 1 billion, right? I have to make sure that it's not breaking, right?
Yeah.
Because right
Yeah.
now we haven't proved it, right? The thing that to prove to work. And then, and to your point about which chips I launch, if I can't have trouble getting the NVIDIA chips from TSMC, NVIDIA will charge me a 70% markup, right? A
Yeah.
70%, actually more. Like it cost them, what cost them $3 million, they'll charge me $10 million for, right?
Mm.
That's a 70% margin that they already have, right? So if I'm going to buy 50 million chips, why do I want them to cost 3 times more than I would like them to cost? I would want them to build my own chips. So
Yeah.
then they will have AI5 next year, AI6 maybe 2 or 3 years after that, and now they have plans for AI7, AI8. I believe the AI7, AI8 will be modified to work for this. So my
Well,
guess
I
is
think there was a post from Elon where I think I forget who it was, because Elon said AI8 will be out of this world, and someone reposted that saying, yeah, that means that's going to go into orbit for
right,
data centers, and Elon agreed.
someone,
So
right,
yeah.
right, yeah. So I agree that they need to do the work, figure out how to modify the chip to go from AI6 to then AI8. And then when I make the AI8 in volume, right, it will be a space version of the chip. I'm not going to have the AI8 space version running around in cars and Tesla bots on Earth. I'm going to have a space version of it. And so then it'll be the AI8 chip. So that will probably be around 2030. And then they'll try and get toward launching it in 2032. For the big data center.
You saying that gets me thinking to the uses of these chips in space. And it's not just, let's say, data centers or AI training on a Starlink network or data centers that SpaceX may choose to build, but it's also Optimus bots that will be deployed in space on the moon and on Mars.
Right.
And chips in Optimus bots in space would need to be space hardened, just like the other uses. So you've got multiple uses for these chips.
Right.
And that kind of coincides as well with the timeline to get to Mars with multiple payloads, with some degree of surety, much ahead of humans landing on Mars.
Right. So what I foresee is that they work on all these issues, work on a chip that's suitable for it. This is the Star Cloud 2, the intermediate step, like go from one chip to maybe, I'm guessing 100 chips in there, right? But still, it's one. So that thing in the top left with the X, where it's got like extra solar panels and that kind of stuff. So there's intermediate steps like this, like a modified version 3 Starlink satellite. SpaceX is going to start launching version 3 satellites. They can make about 30,000 or more of them. They'll go from 800 kilograms to about 2 tons for the version 3.
The version 3, yeah.
Yeah, and the version 3, so 2 tons about the size of a large car, or, like an SUV-ish car, or actually 2 tons might be the weight of a Model Y. So you're in that weight and size of thing for the main heart of it, and then you have the panels, the solar, they're coming off of it. They're size of 1/10 of a football field, right? So a lot to build. So the development path that I see is that you start tossing chips into a version 3. I make a modified version 3 that has 8 chips, 10 chips, going up from the 1 that StarCloud has, right? And then I would then work out the issues around that. So I designed my AI7, AI8 chip to do the thing they need to do, right? Because they maybe need to have error correction. I need a fault tolerance, things like I'm being hit by more cosmic rays. So I need to like be able to handle it. Even with shielding, it won't be perfect shielding, right? Like especially a cosmic ray, no matter, I'd have to have like insane amount of shielding that's too heavy to block out cosmic rays. So I'm not going to block it out. I'm going to be hit by them. So I need to like handle it and then handle the temperature things. So they will need to work that out. They have an advantage in that they already have put up AMD Versal chips into the Starlink satellites. Those are not full GPUs, but they are fairly advanced chips, right? So SpaceX has some experience knowing what happens when those chips are there. So they have some design things. So one, they have the launch cost.
And I would imagine they're taking into account all of their learnings and applying their learnings to AI8, AI7, and AI8 when they design these chips that eventually go in.
Right. But there's no reason to rush to an NVIDIA version that costs 3 to 4 times more.
Yeah.
Right, for an at scale thing than if I just wait and get my own chips going.
Yeah.
And probably both projects would need to have modified chips.
Yeah.
Right. For the
and I
space.
think Elon's also pointed out recently that the advantage of their learnings being applied to their designs of their chips is that they can do away with so many parts of their chips. It's a far more elegant design for the Tesla chips because NVIDIA chips are more generalized chips. Right. And the advantage with Tesla chips is that they're very specific to the needs that of the use cases that Tesla wants to put them to. So it's all kind of coming together.
Right. So the thing is though, like I said, at 200 megawatts for this, in terms of all solar power we ever put up there, if you want to scale up to, going up to gigawatt is basically what the next plan is for the version 3 satellites they're looking to put up. So they're looking to put up 30,000 to 45,000 of those version 3 satellites, they'll probably have 50 kilowatts to 100 kilowatts of power each, and maybe an AI version might go to 200 kilowatts. So they will have 3 gigawatts, 5 gigawatts of power from the whole constellation, right? So, and then adding on some chips where they have a bit more chips and a bit more solar, making that incremental change would be the between 2026 and 2029. They'll be doing more flavors of version 3 with AI, putting more chips in it, learning, doing a few hundred of those. But for them to go to the higher orbit, they must apply to the FAA to say, hey, I'm going to launch 100, 1,000, tens of thousands of satellites to that higher plane, because they haven't got permission to do that yet.
Right? Yeah, because the other thing is, I mean, the lower the orbit you're in, the more number of times you're crossing the terminator line in a 24-hour cycle. So you want to reduce that to a maximum. If possible, you want to get into an orbit where you're perpetually sun-facing in one direction, so that you're absorbing the solar energy at the optimal, and your radiators are facing out to space, so that they can dissipate as much heat as possible.
Right.
And for that, I mean, so this is a bit unprecedented because
right. So there's a lot of stuff to work on. It's like, even if you're testing and going and willing to break things and go way faster than NASA and all that kind of stuff, it's like we have not done any of this yet. We just got the one satellite up with one chip, right? And we haven't tested. We haven't learned what you need to learn from that.
Yeah, right.
So you need to learn that. One, everything's too expensive right now. Maybe the solar isn't the right price, but then the radiator sizes and then the scale of solar. We need to deploy gigawatts. We have not deployed gigawatts yet. We have not built gigawatts for space, right? So there's many, many steps to get there. And so the ultimate endpoint, I think, will be a bigger version of a version 4 Starlink satellite, optimized for AI, with solar panels, optimized for the AI use case and for the orbit you're going for.
Okay.
And then chips that are fault tolerant, chips that are made by Tesla and SpaceX for this purpose, tested for a while, right? Because you're not going to just say, it's all going to work. I'm just going to dump the money in just to launch. No, you have to make sure it works. So there's a period of time where you need to make sure it works, and then you'll scale up. But the ultimate endpoint is space data centers will be cheaper than on the ground. It will be cheaper than the ground. That will happen. I think it happens 2032 to 2035, right? The launch part of it goes cheaper, but then the rest of it has to be cheaper and proven, right? And you have to scale up your supply chain. So this will go that direction. Jeff Bezos talks about 10 to 20 years, and all AI data centers will be in space. I also think that you will move AI data centers to Mars. In my book that I wrote with Randy Kirk and Phil Bess and others, I said the Mars aspect would work. The reason for the Mars aspect is, yes, I'm not 24-hour sun, right? But if I have the factories to make my solar panels on Mars, because the materials are there, silicon, steel, etc., right? I can build the factory and make it there, so that I don't have to build it on Earth and launch it. I can just send the mining equipment and the factory production, and then
have
build
them
it
built in situ. Yeah, you can also have small modular reactors go up there, because there'll be a lot more storage, stability in the supply, and you'll also probably have some version of the mega block deployed on Mars, because as we've seen, data centers on Earth spool up and down in their energy needs, at fractions of a second. And that's where the mega blocks and the mega packs are so useful, because they can balance out those loads.
Mars also has the advantage of having, in ice form, a small ocean of water.
Yeah, right.
So then I can do water cooling on Mars and get things closer together and do stuff that way.
And of course, you send up legions of optimists to do all the hard work for you, the grunt work for you.
Right. Elon talked about doing 100 terawatts per year from the moon. Right. He talked about getting a mass driver. In the same post, he said 100 gigawatts in about 5 years, and then saying going to 100 terawatts in some unnamed date from getting moon assistance. So from the 1970s, in the first, hey, we did Apollo, everything's great and wonderful, everything doing in space, there was the L5 Society and Gerard O'Neill, who said, hey, let's make giant colonies in orbit. And then those people realized, hey, we could cut the cost of building a giant colony by doing the mining on the moon and then sending the materials from the moon. And then because of the gravitational differences, it'd be far easier to send it to orbit from the moon. So the issue with that is, once I get the cost of the launch and cost of the solar way down, right, then everything is the cost of the chips. Because the cost of the chips right now is about 60 to 80% of an Earth-based AI data center, right? So once I cross over, and so the other part, 30% is cheaper in space, the chips, they said, hey, that's still the same, right? Even though whatever modification I make, I'm saying that the different flavors of chips end up being roughly the same. If I drive the cost down, already it's half or a quarter of Earth, and then I say, hey, I can make the things cheaper on the moon, that drives the non-chip part down to like 1%, 2%, right? But until I make chips on the moon or on Mars, the bulk of my cost is still chips, right? I still got to move the chips. So getting super cheap on the moon does not change things because I still got it on my chip problem, right? So I need to create massive fabs on there. Otherwise, I'm still have my cost does not get cheaper than chips because I'm still making the chips in the regular way on Earth.
Yeah, but that's also super long term, isn't it? And you're talking about fabs on the moon and on Mars. You're looking at
long term,
2040, 45. But it just, there's also the advantage of having so much of thorium on the moon. And we know that China has quite a serious program to exploit thorium and other resources on the moon. So you could have small, again, for power generation, you don't need to be that dependent on solar on the moon, because you could have in situ development of the thorium resource on the moon, small modular reactors, do a lot more.
So the huge advantage of what we're talking about here, if we're spending not the $2 trillion for the 100 gigawatt, but we're even getting up to the gigawatt level, and we're spending tens of billions of dollars to develop massive power in the gigawatt level for Earth orbit and for the moon and for factories there. That gets us over the hump of, we want to industrialize space. We want to have factories and stuff there, because everyone's like futurists like me. We're all thinking about, how do we get the motivation, the economic reason to spend $100 billion to do something? Like, oh, we're going to spend $100 billion, we're going to make a space station. It's because governments want to do it and they're doing whatever stuff like that. If there's a commercial
for private entities, commercial is different.
Right. So now there's a commercial reason that we spend $100 billion and a commercial reason that we develop the factories, the mining, and everything that we need to do. And now everything in space has become cheaper than on Earth for certain applications, right? So I got the launch, including launch, I can put solar up there, and it's cheaper than power generation on Earth. Once I cross over the line, where it's like, now my cost has dropped below, now everything in space becomes economically driven and commercial. And now I'm building, if I'm developing terawatts of power on the moon or terawatts of power on Mars, it's because it's cheaper than doing it here on Earth.
Yeah, it's funny you say that, Brian, because it's I don't know if you felt the same, but in these past few weeks we've seen the feud and the growing divide between NASA and Elon, primarily because of Sean Duffy, right? And it seems Elon's now decided, to hell with it. We're going to go and SpaceX will build moon-based Alpha and do whatever it needs to do because it has the capabilities to do it, to go it alone. And you're no longer dependent on a government agency like NASA, you're no longer limited. Although, according to the Outer Space Treaty, it would be the American government's responsibility to oversee the activities of SpaceX because it's an American entity. But the rules for space exploration, resource utilization, it's pretty much like the wild, wild west right now. And there's no reason Elon couldn't decide, hey, let's just, to hell with it, all the bureaucrats and all of this red tape. Let's just go and do it because we can do it ourselves.
So several points to that, which you're correct on, is that this year, 2025, SpaceX is profitable already. Okay, they have 8 million, heading to 9 to 10 million customers for the high-speed internet that they have, Starlink high-speed internet.
Starlink,
right?
Yes.
So that is over $10 billion of the $15 billion that they're making, $5 billion for various forms of launch and stuff like that,
Yeah.
and also the NASA contracts, right?
The contracts, yes.
But they already said the NASA Human Landing System contract is only paying them 10% of the cost of the Starship development. So basically, that $2.9 billion contract, they're spending $30 billion on the development of Starship. Okay, so and then next year they'll go to 20 to 30 million, maybe 40 million customers for Starlink. Okay, it's the rate there is, and how much they go to is how fast can I build the dishes?
Yeah.
I already have the satellites up there. They can handle all the communications that we need already.
Yeah.
Even if I stop putting up another 2,000,
Yeah.
I already
and the
have
speeds
enough.
have already been going up with the existing network.
Right, it's already going up. Right. So then next year they'll be at $30 to $50 billion worth of revenue. So that means they'll have 20 to $40 billion worth of profit. They will have NASA budget or double NASA budget in profit. Right. So and that'll be at $40 billion, that will be 13 times more money than this HLS contract.
Yeah.
Right. So they will be the economic driving force for space. Right. So that's already happening next year. And then when they get the B3 satellites all up there,
Yeah,
20
that's a
times the
whole
capacity,
different game. Yeah.
20 times the capacity of that, they can have 200 million customers, way better service on high-speed internet and for cell phone. So they'll go to $200 billion to $400 billion of profit, which is double to 4 times the last 12 months of NVIDIA. So NVIDIA, worth $5 trillion, has about $100 billion of profit, per year. If they go to 200 to $400 billion in like 3 to 4 years, SpaceX becomes a $20 trillion company, right? So by 2029, they could be at $20 trillion, right? And they're making, this $200 to $400 billion worth of profit before they build their first major AI data center in space.
Yeah.
The AI data center in space thing, where it crosses over and is cheaper than all data centers on Earth, means in the 2030s, they will make trillions of dollars of AI data centers in space. Whether it's on orbit, moon, Mars, it will be there, and it'll be cheaper to do it out there, right?
Yeah.
And it'll be industrialized in factories. So the good thing is the AI data center insatiable demand will drive the development of space. We will get the solar system with Dyson swarms of AI satellites. Dyson swarms being Dyson sphere, cover the sun with that collection. That future is from the insatiable demand for AI.
Yeah.
Right. So once we cross over and it's cheaper, the trillions of dollars that the hyperscalers will spend will go to this development, and that will drive all of the development of the moon. At the point at the start of this thing was, the future will look like the future. It will be all space. It will be all AI. It'll be all bots. It will be because we're spending trillions of dollars on AI that we will have thousands, tens of thousands of Starship launches giant factories on the moon, mass drivers moving it all around. It's because we need this trillion of dollars for cheaper AI. So, but still some things to get there. We have to make it cheaper.
Sure.
Once we make it
Yeah.
cheaper, then it's like the what Elon called the AI supersonic tsunami happens. The AI supersonic tsunami happens across space, orbit, moon, everything, because AI is exploding outwards, and it'll be combined with space. AI and space together is where it's going to go, and that supersonic tsunami going out will give us the whole solar system, which is 100 billion times more power than we have now, right?
Yeah. Sure.
And then how fast that happens? How fast do we double? Every year? Every 2 years? Doubling quickly, 100 years is going to look, like a pretty full solar system.
Yeah. It's pretty mind-bending.
Yeah.
That's a future I want to see.
Yeah, that's right. And it'll look great.
Boy, that'll be fantastic.
And the fact that it could be in 5 to 10 years, a lot of this could happen.
Yes, that's
Brian,
launches. That's the crazy bit. It's just within reach. 5 to 10 years is nothing.
Right.
It's a 5-year plan by the Chinese Communist Party.
Right.
Goes by like that.
I know. And the thing is that the SpaceX, having the money thing is like, if you're making $200 billion a year, $1 trillion a year, the $3 billion government contract, take it, give it away. Who cares? And I'm landing, like constantly on the moon, making a moon base because I need to have the factory. It's not because you're telling me to go there and plant a flag. I need to develop it so that I can make my $1 trillion, my data center that costs $2 trillion cheaper.
Yeah. And I think that's the problem with the focus of NASA right now, that it's still stuck in the last century in the way it's doing stuff. And the clear competitor, China, has exactly this approach to space exploration. And they're very clear about what they want to do. Look at their space station. Look at their program for the moon. It's just, were it not for SpaceX, I think NASA would be in big trouble.
Yeah, it's basically, to go back 100 years, like the first uses of planes, was for World War I military, for some fighting there, the Red Baron fighting American planes and biplanes. And then shortly thereafter, there was the early mail delivery by plane.
Yeah.
So those two things were very government focused. But then afterwards, it was commercial passenger travel. It was, uses for agricultural crop dusting and that kind of thing. So you go commercial, and then the commercial is 20 times, 100 times.
Yeah,
that's where you scale, right? So we're getting out of the it's all government and government money.
Yeah.
Next year, like I said, SpaceX gets more profitable than NASA, and then that's where the commercial part takes off. And having this commercial driver is what's going to give us, thousands of starships. We'll all be able to get cheap rides up there. We'll be able to, the cost of delivering something to orbit will be less than the cost of sending an international package, by plane or something like that.
Yeah.
And then doing the deliveries to that. So once economics take over, then we get the future that we want.
Yeah. Wow. That's going to be some future.
Yeah.
All right. Shall we go back to your slides?
I think we have them. If you want to see something, if you want to go over a particular slide, so I can step through them. So this is the size of the 1.5 Starlink, the version 2 minis are up there now, and the version 3. So they're getting bigger and bigger.
Yeah. And you're saying there's going to be a version 4 as well.
A version 4 and maybe a version 3 AI version that would have more panels or a bit bigger and that kind of stuff.
Right.
And then this is a description of how they're going to pack the equipment into a container-like thing. This is a plan for StarCloud.
Right.
The packing them in a current 72-chip system weighs 1.4 tons on Earth, at the rack on Earth, because it's not just a chip. There's memory and networking and a bunch of other stuff. It's really heavy stuff right now that they need to make lighter. And I think other data don't need the numbers. So there's some others working on, Celestial's working on thinner solar panels that roll out. And then there's the folding one that are currently being used by SpaceX for their Starlink. They fold out like this. This is called a Z fold. This is the rollout thing that's on the space station. And this is the size of it beside some people. So you look at that, and the ones that are on a version 3 Starlink will be 2/3 as tall. So still taller than a person that you're seeing it. So these things, when you say, oh, look at that little thing, it's like these things are big already, and they're gonna get bigger.
There's also this really, really exciting startup in Europe called Lumina, and I interviewed the founder and CEO. What they're doing is that they're using that they're generating solar in space, and they're beaming the energy across to client satellites using lasers. So I think that's again another solution where you don't need to have power generation on the same infrastructure build as you have your chips. You could just have your solar farms in space at a better orbit, at the most optimal orbit, and then just beam that energy across to the entire data centers via lasers. I think that's. I think the U.S. government is also looking at one of those at solutions like that, but I mean the possibilities are pretty mind blowing.
Right. So they already have laser communication between the Starlink satellites. So
they do.
They do direct laser communications there. Beaming power is being demonstrated. It's only at a few watts of power now. They have not done high power versions of that. I've talked to the companies. We have to do another show to go over that aspect of power beaming. But Elon on the, I think, All In Pod or Rogan said that he doesn't think that beaming power makes sense. He thinks it's better to do it, especially beaming down to Earth. He thinks it's better to do it localized in space.
Thank you so much, Brian. It is always such a gold mine when I talk to you. It is so much fun. Thank you so much for your time. I absolutely love our chats and learn so much from you. Thank you.
Talk next time.